Now, I was talking about math expressions, and math expressions can be typed in, as you saw, as JavaScript and are evaluated. Well, JavaScript code is really just a bunch of expressions, and that's any set of literals, variables, operators, and expressions that evaluate to a single value. So if we go back to our console here, you can see that we have a math expression, and let's figure out what these things mean here: literals, variables, and operators. Well, I hope you remember what an operator is. That is the plus, the divide, the multiply. That's what's telling us what the action is that we need to do. The literals are things like the numbers. And we'll also be looking at using strings as literals, which is something like a word, hello. And then also the variables we will cover later. What does it mean that an expression can have an expression inside of it? Well, that means that we could have 8 plus 2 plus 3. So here's an expression, 8 plus 2, and that is part of the expression that we're adding 3 to. So we can have multiple expressions linked together. If you want to learn more about expressions, here is a link you can follow and read up about expressions. Let's look at comparing using a calculator and evaluating expressions in JavaScript. So we can punch into the calculator an expression, maybe something like 3 plus 4, and we get the answer 7. And we can do the same thing, 3 plus 4, and we get 7. Let's take a slightly different example. What if we had 3 plus 3, and then we divided that by 2? Here you can see we've got the answer of 3. But if we put that into our JavaScript console, you can see 3 plus 3 divided by 2, it's giving us a different answer. It's giving us 4.5. Well, let's look at what's going on here. On the calculator we said take 3, add 3 to it, then divide it. And you can see that it adds the 3 and the 3, giving us a 6, so that when we divide it by 2, we get 3 again. But what is happening on the JavaScript console? How are we getting the 4.5? What's happening is that in JavaScript there's an order of precedence defined, and that says that all multiplications and divisions must occur before any additions and subtractions. So what's happening is the 3 is being divided by 2, giving us 1.5, and then that 1.5 is being added to 3, giving us the 4.5. And if you remember your math, that is the correct order of precedence. It's just that the calculator is giving us, is calculating the intermediate results right away, whereas the JavaScript is actually following the mathematical rules of precedence. So we have an entire table that sets our order of precedence. So here we can see that multiplication and division are going to be executed prior to addition and subtraction. And not we're going to learn about later. And what's this percent sign? That's actually the modulo. So that's determining the remainder. So if we take 6 divided by 3, we know that it goes in 2 times. You can take 2 3s out of 6. If you do 6 modulo 3, that's what is the remainder? Well, 3 goes into 6 evenly, so there's nothing left over, so the remainder is 0. But if we have 7 and we do modulo 3, then we say, okay, well, 2 times 3 is 6, and then we have 1 left over, and that 1 can't be divided by 3 without creating a fraction or a decimal. So we're going to say that the remainder is 1. And so that's something we learned a long time ago in grade school when we did division and we found remainders, and it's very useful in computer science, so we'll be using that, and I'll be showing you how it works. Comparisons are then done after the multiplication, addition, subtraction. Then we do the comparisons, then we do the equals comparisons, and then we do these Boolean operators. So we're going to talk about all these operators in detail in this class, but for right now I want you to understand the multiplication, division, modulo, and the plus and minus. So in order to calculate an expression as intended, sometimes we need to use parentheses. So let's say we want to find out what the average is of these numbers. So we have 1, 2, 3, 4, 5 different numbers. So if we add them up and divide them by 5, that should give us the average. So let's take a look at that on our calculator. We can say 7 plus 3 plus 5 plus 8 plus 6, and we want to divide that by 5, and that gives us an average of 5.8. And we can kind of look and say, okay, well, you know, it's less than the greatest number, it's greater than the smallest number. Yeah, I can buy that. That might be the average of those numbers. So let's look at the JavaScript console and see what happens if we want to find the average of these numbers. So we have 7 plus 3 plus 5 plus 8 plus 6. So there we are, 5 numbers, and now we want to divide that by 5. Well, what do we know about the order of precedence? Well, we know that division is going to happen first. So the 6 is going to be divided by the 5 before all the addition takes place. And you can see we are not getting an average. 24 is much greater than any of those numbers there, so it can't possibly be the average of that set of numbers. And it makes sense because it's following the order of precedence. However, it's not giving us the answer we want. We wanted to calculate the average. So we can change that by using parentheses. Whatever we put in parentheses will be executed prior to following the order of precedence. So if we put in those numbers now, and put them in parentheses, and then we go ahead and divide it by 5. Now we're going to get the same answer as we did on our calculator. We're saying first add all these numbers together, and you're telling the JavaScript processor to do that addition first by putting these parentheses, and then go ahead and do the division. So that's one of the ways we can change how the mathematical expressions are evaluated. By putting in parentheses, we can tell it explicitly, yes, do that addition first, and then do the division. There's also another way to have certain expressions being evaluated before other operators are applied. And that's storing our intermediate result in memory. We can also do this on the calculator. So if we had 7 plus 3 plus 5 plus 8 plus 6, we can get that result with the equal sign, and then we can say, please store that for me. Then we can clear out, do whatever we need to do, and then we can say, oh, recall that for me, that number I stored, and now that's the number I want to use to divide by 5, and that gives us our 5.8. So we have been using memory on calculators, and that's one of the key features of programming, is storing things in memory, and we're going to be learning about that next, and that's going to be for variables. So so on your calculator, there's only a few places you can add store to memory, but on your program, we store intermediate results by giving it a name, and that name is referring to a place in the computer memory, and then when we want that value back, we just call it by name. So if we say, I want a variable, I want a place in memory, and I want you to call it sum, and I want you to set it equal to this expression that we've been adding together. Now, because we stored it in the sum, it's not giving us the value back right away. But if we type sum and say evaluate sum, it says, oh, that's where you wanted me to store that expression of adding those numbers together, and that number is 29. So just like the memory recall, it recalls that information, but we get to give it a name. Then we can just say, oh, take the sum and now divide that by 5, and we get our 5.8. We'll be discussing a lot more on variables later.